Hello guys, in this video we are going to check out this problem, split linked list in parts. So here basically we have been given single linked list, the head of the single linked list and a integer k, and we have to divide this linked list into some parts of k, consecutive linked list. So there are some conditions to be followed. It's like the linked list, each part of the linked list should be of same size, or there should be a difference of 1, and the first occurring parts can have a size greater than the next one. So let's take this example of linked list 1, 2, 3. Okay, if we have this linked list and we have the k is equals to 5. So basically what we have to do is we have to divide this linked list into k parts. So now as we can see, the length of the linked list is 3 and we cannot divide it into 5 parts. So the question says that if it is like that, the rest parts should be null. Okay, so it will be some 3 parts filled, and then next two will be null. So here the 3 parts will be like 1, 2, 3, and the next parts will be null, and this is your answer. So here basically we have to return the heads of the linked list. So here 1 is another linked list which is head as 1, and its next will be null. So here a linked list which is its head value is 2 and its next value is null. Here similarly for 3 also, here we have only a single node which is basically null or a null value. So how can we approach this problem? Let's take a look at another example. So if we have this example 2 here, and the length of this linked list is 10, we have 10 nodes there, we have to divide it into 3 equal parts, or likely equal parts. So what they have done is, since we have, let's consider n is equal to 10, which is the size of the linked list, or the number of nodes in the linked list, right? And k is equals to 3. So basically now if we have to divide some 10 into 3, let's say if we have 10 chocolates and we have to divide it into 3 parts, how we'll do it, we'll divide 10 by 3. So basically our each part will have 3 elements, right? And there will be one extra. So here also we have like we will consider something like part size, which is equal to n by k, which is equal to 3. Okay, and will also have some extra because 10 by 3 will give a remainder of 1. So we can have our extra is equal to n mod k. The mod gives us the remainder, right? So 10 mod 3 will give us 1. So we have each part, we should have 3 parts, right? We should have 3 parts. Each part would have an linked list of length 3, but one linked list will have a extra node with of size extra node. Okay, only one linked list. So extra here defines that how many linked lists inside our answer would have an extra part. And since we should have that extra one at the starting of the entire answer so it will be if you have now here, since we have only one, it will be at the first result, the first linked list. So now how we can solve this question, right? One thing is that we have to return the heads. So if we have this one this output, as we can see, so this is basically 3 different linked lists. Okay, so let's consider the previous one again, because it's easy to draw here. 1, 2, and 3. So as we know, we should have 3 linked lists in our answer, and the null values. Let's keep the null values besides and focus only on the values which needs to be added in the linked list. Okay. So our head will be this value, that is the 1, and then we have to find how we can not include the next value. So basically, if we have only one this value as the head, if this is the head and its next should be null, and the second one, this should be the head and its next should be null, not this one, right? Not 3, it should not point to 3. Then 3's, this should be the head and its next should be null. So basically what we have to do is we have to find a head which should be the new linked list, and we have to find the last element of that linked list, and it should be the null value. So let's consider this example 2 also here. Okay. So here we have this 1 should be the head, right? 1 should be the head. Then next of the 4 should be null. 5 should be the head. Next of the 7 should be null. And we don't want this, right? We don't want this connections. We want head and then its next should be null, right? How we got this 4? This 4, how we consider only 4 elements? Because we have to divide it into 3 equal parts, but since we will have one extra part, we'll give that extra part to this linked list, right? Okay. So now how can we code it? Let's understand. So the first point is we have to calculate the length of the entire linked list. Okay. So we'll calculate n. First is the length of the entire linked list. Then we have to find the part size and the extra elements. Okay, so we'll find the part size and the extra element. We also have to create an answer vector which will return it. Okay. Then the next part which we have to do is we have to iterate over this, and we have to find the new head of it. So we have to find a new head, and then we have to also check the elements, which element we have to add, right? So here we have 4 elements to add, here we have 3 elements to add, here we have only 3 elements to add. So we have to determine how many elements we have to add. Okay, so we have to determine how many elements to add. Then we can create a while loop, and it travels through all the elements and see if we have to add that element or not. Okay. So now let's discuss this traversing part, how we can do that. Okay. Rest part we'll discuss in the code itself. Okay. So now if we have to discuss this traverse part, first we have to determine which elements we should add. Okay. So to determine which elements to add, we have first we initialize a variable add, and then we have to calculate if the extras, so here in this example we had extra 1, right? Here we had extra, this extra is 1, so currently we have extra is 1 and a part size is 3. So if our extra is greater than 0, our add will be part size plus extra, else it will be our add will be just the part size. And also we have to reduce our extra because we are using here, and we'll be having a while loop, right? And then after doing that, we'll get a variable called as add. It will be an integer number, and that much element we have to add in our linked list, right? So for that we don't have to create a temporary something extra, okay? But we will just return this head. So initially our new head will be this the previous head which we had. We'll traverse through each and every element. We'll find the last element, this element. We'll find the fourth element. We'll just do its next part to null. Okay, so fourth next we'll do it as null, and we'll just increment our normal traversing variable to this pointer. This pointer will be our new head, and we'll just continue the process. The next process will be like we'll find now here we had add is equal to 4, but here extra was 1. So now after using here extra here in this linked list, in this part of the linked list, we'll have extra as 0. So here we'll just travel for the we'll have this else executed and we'll come here 7. So for this 7, what we'll do is that we'll do 7's next is equal to null, the traversing variable. We'll put the traversing variable ahead one node. It will be it will be uh, declared to our new head like that, and we'll just continue further. So now let's discuss this part into our code. And one more part we have to do for the rest of the elements, like for the example of first example, we had only 3 elements and the rest 2 elements were null. So we'll just decrease the value of k, I'll show that, and we'll have some value of k which is unoccupied. So here for this example, here in this example, we'll add 3 times this elements. So our k will be left with 2. So for this next 2, we'll just add this empty thing. Okay, so now let's go up. Okay. So let's declare n will have a vector of list node y. Will now we are basically finding the what you call we have to find the length of the linked list. So we'll also have a node, a traversing node, which we call as current. Okay, it will be our head. While current is not equal to null, current is equal to currents next and n plus plus. So till here we get the value of n. Now we have to calculate the part and the part size and extras. So our part size will be n divided by k, and our extra will be n mod of. Okay, and now we have to do the last iteration. But now we also have a new node, right? New head, list node new head is equal to our previous head, and let's point our current to our current head. Okay, now we'll have a while loop, that is the traversing. We have to traverse the entire linked list, so till it's not null. What we have to first do, we have to first calculate how much elements we have to add in our linked list, right? So int add, so we can initialize it to 0, but so if extra is greater than 0, then we have extra elements, then our add will be part size plus 1, and we'll do extra, remove the decrement extra, else our add will be part size. Okay, now if our add is greater than 1, what we'll do, and our current is not equal to null, because we are going to access a node, so we have to put this current not equal to null inside a loop. Current is equal to currents next, and we have to decrement the add. So why we have done it 1 here? Because see, for example, if we have this only one here, we have only one node in our linked list, right? So we are not adding it here. If we add greater than 0, then the next will point to the second node, right? If our add, if it was like here 0, then we will have traveled it once, but we don't have to do that, right? Now if our current is not equal to null, okay, so if we are not at this third the next of this third, right? If it is not null, then we'll increment to the next part, right? If we are in 1, because now it is not null, right? So we'll just have our next of the next element. So list node will store this current in our current next in a temporary node. Okay, and then we'll point the currents next to null because we want to cut off this, right? So we did this operation here. This after 4, the next will be null. So we did this now, and then we have to add to our answers. Push back the new head. We'll also change our new head to 10, and our current will be 10. So now our new head will be 5, our current will also be 5. If we are at the last element, like if we are just at the 3 and we don't have any next element, right? So if else just push back the head, new head. We don't have to write a new head, new head. Okay. And for all this, what we did, we have added or inserted ones into our answer vector, right? So we have to decrement the value of k. Now y k is greater than 0, we'll just push back, like add just the null values, because there won't be any linked list there, and decrement the value of k. So this part which we did was for just this element, like 2 elements, and we'll return answer. Let's run. And submit it. Okay, so we submitted this question. That's it from this video. Thank you.